All right, so welcome with this tutorial, also for the viewers at home, I guess, who will just view this recording. So what I have set up so far is I have a Python project here. I'm using PyCharm, and I have the Social Interaction Cloud code here. I've downloaded or I've installed all the requirements specified here. And the only example that I've left in here is the speech recognition example. I will go through it, but then afterwards I also will create new code demonstrating some other functionalities. But first, I think a big part of the interaction you're going to create are the speech interactions, conversations. At least some part of the interaction will be the conversation. So it's very useful to know how to indeed integrate with Dialogflow. I can also use this to explain the difference between waiting actions or regular actions or loading actions and then running them. To maybe take a step back first and introduce briefly the overall architecture. I think there are videos online that I created, I think 2 years ago already, that explain in more detail how the flow of all the processing that happens works. But to quickly summarize, we have a robot. I have one here. I have another camera. You can see the robot now on the screen, right? Yeah, great. So I will demonstrate using this robot. So the robot, so there are basically 3 components. We have the social interaction cloud and the services that are a part of that are running on your virtual Docker server. We have the robot and you have your application, and you connect them all using, this step, etc. The robot installer, but I guess that's discussed in other videos. How to do that, pretty straightforward. But what happens is that if your application sends a command to the robot, the application has no knowledge whether the robot actually executed the command or whether it's finished doing the action or what the result is of the action. There is no, so if you would just send commands, the robot would just simply, your program would continue while the robot is still, if your program is already on action 6 or something and the robot is still processing it and executing action 2 or something, then you get out of sync. So this is called asynchronous programming. All your different components, they do not wait for each other, and they are operating independently of each other. So that's why we need some additional software or additional steps in our code to make sure your application is waiting on the robot to finish basically executing the actions. And that is also the difference between using, I'm going to show this, zooming in. So we have the ActionRunner. I instantiated it here in the init, and it has different functions. So we have a run action and a run waiting action, and they basically just do the same thing. They just start an action. The only thing is that the run waiting action has an additional part of the code that makes it wait until the robot is finished. So the robot actually generates events. Those events are interpreted by the social interaction cloud, and that generates again its own events. And those events can be you can make your software basically wait until such events come in. So an event can be, for example, if you're saying something, then an event that comes back is text done. That basically tells your application that the robot is done talking with the piece of text you just sent. And the run waiting action actually waits for that event to come in, and the run action will just continue after it sent the text, but will not wait until the robot is done. Sometimes it's useful if you want to do stuff in parallel, but there are also other ways to do that. And that is the load waiting action. So you can, if you want to create blocks of actions, but you want to make sure that all the actions are done processing by the robot before continuing your code, you can preload them by running the load waiting action. And it's just the same input as a regular action or a waiting action, but it won't execute. It won't execute until you call the run load waiting actions. And this makes sure that these actions are now run in parallel, basically. So it will set the language to English, and it will call the wake up action, which makes now, if it's in a crouched position, like it is now, then it will make it stand up. That's basically what the wake up action does. So that's the first global part of how the processing works. And by just combining different actions, different waiting actions, or you can create blocks of code, and basically you can create, it can be quite a long script to do everything. So it's, I think, also smart if you're going to make more extensive applications to trying to come up with a way to break up your code in modules, or in this case in different functions, and then call the function whenever you need a block of code to execute, to structure your code a bit. But that's up to you how you do that. Basically, if I'm just going top to bottom of this speech recognition example, is that it's just a class with an init and some methods. The main method here is the run method. And in the end, we will just create an instance of that class and call the run method on that instance to make it run. During the initialization of this object, we need an instance of our basic SIG connector. So there are two connectors. We have an abstract connector and a basic connector. The abstract connector is basically just an overview of all the options. And the basic connector is a simple implementation of this. It's basically this interface. This basic connector is an actual concrete connector. And this basic connector has the code in it for creating, like, registering listeners to events and stuff like that, to make actually possible to let the code wait for events. And the action, all the code and the actions, this is all necessary to create the waiting behavior, basically. I think there are other videos and also some documentations on the Confluence wiki on how this actually works. But we're using the basic connector, and here you can also find all the things that you can do. So we have all kinds of events, and there are different events handlers. I will go into this in a minute. Some speech recognition functions, and then some vision functions. I'm just scrolling through it just to give an idea where you can find it. You don't have to read it right now. And all kinds of actions. I will just say, go over it, see all the possibilities. And I think in the abstract connector, it's basically the same, but I think here, I'll just scroll down directly to the actions. You have more information about what the action does. And sometimes there are references, for example, I saw some questions on the Slack, I think, about how to set the LED colors. Well, there are also references here to the documentations of the Now robot, where you can find more information about the variables that you need to enter. So this is basically also the documentation you need to call these functions. That's in the abstract connector. So back to our speech recognition example. We're making an instance of this. We're creating an ActionRunner. So this is basically the overlaying code that helps us manage the waiting behavior, waiting for actions to actually finish before your code continues. Then to the speech recognition part. So as you probably are aware or have experienced before, is that speech recognition is not flawless. So there are bound to be errors, or speech recognition is not recognized. And you want some management code to give the people that interact with your robot some additional chances to get their answer in. And that's basically what all this code is for. Eventually we're going to build a user model that collects some information about our user. The only thing that we are now interested in this example is the name of the user. So we want to end up with a user model where there is this entry with the user's name. And this is the recognition manager that has keeps track whether an attempt is successful or not, and how many attempts there have been. And basically with this statement, we're gonna loop over sending, basically loop over asking the question over and over again until either it's successful. So it will loop as long as it's not successful. So if it's successful, it will break out of this loop, or if we have more than 2 attempts. So basically the user gets 2 attempts, and if you want to up that number, you can just increase this. And what happens is that we'll just ask for the name of the user and then call the speech recognition. So if we're gonna go the run waiting action here, the first argument is always the action, and the action that is the same as the function name in the basic connector. So if we're gonna see here, we have I think this is maybe, yeah, so we have the function here, speech recognition. And we can see here what the input is. So we're going to supply a context, a max duration. And if you want to do something with the result, we're going to need to add a callback function there. But how that works, I will explain in a minute. So back to the example. So this is the context. This is the number of seconds it will maximally wait. So if there is an answer within, like after a second or 2, then it will already return with the answer, but it will at least give the user 3 seconds to answer. For short questions, this is enough, but if you have longer questions or like where you expect a longer answer, you want to increase this number. Otherwise, the robot will continue after 3 seconds while it will interrupt the user giving their answer. So you can play around with this based on the answer. Like I said, we want to do something with the answer, and that's something we can do with callbacks. So you have to use the label additional callback here. That's just an annoying way how it's currently implemented. If you don't do this, it won't work. And then you can basically define a method that can receive the input, and that is the method that we defined here. Let me see if I can go back. So those methods, they are related to I guess these ones. Yeah. So I see this is already a new name now, but anyway, the speech recognition will return an intent, which is basically a detection result, which is a dictionary. This is generated by Dialogflow itself. This is one of the trickiest events, I guess. So I will go over it in a minute. Like maybe now. So the speech recognition, the way we use it, we always expect intents, which is basically so what the speech recognition does is it parses the audio to text and then analyzes the text to see if there is an answer in there we're looking for. And by giving the context, that's also a dialog input function, which is here answer name, which corresponds with the context label, which basically links it to one or more intents it can recognize. Usually we're just using one intent it can recognize, but theoretically you can have a lot of intents that are linked to a context. And I will show how that works also in a minute. So the result of the speech recognition is always an intent, and if there is no intent there, so either it will just result in a null or none result, which means basically nothing is recognized. So you want to check for that. You want to check if there's an actual intent there. And in this case, we're also specifically looking for the answer name intent. And because we're interested for specific information in what the user is saying, we're also checking whether there are additional parameters and whether the name parameter is part of it. And if so, then we're gonna can actually add the name, can extract the name from the detection result and add it to our user model. So how does it work for Dialogflow? Maybe this will work. So you can see both Dialogflow and the code, right? Yeah. So I have a whole bunch of intents here in my agent, but I'm now looking for the answer name. There's this one. So there are basically three things you need to specify when you're creating a new intent. This one is already created earlier. is the context. So the context aligns with this label here. And you enter it here and make sure that this value is 0, because if you create a new intent, it will be default 5, but we need to set it to 0. And then you need training phrases. You can just enter whatever, and then add the label to it. Well, there is some intelligence here, so it adds, oh yeah, you want this name to be extracted. So the second part is so the context is this. It's a bit confusing because we're using the same labels for different things. So to make it more clear, the action name here is basically the intent name that gets sent back. So if I would change this to, I don't know, name of user to make it more clear, save. This is the basically from the detection result, the intent that you get back, the label that's connected to it, name of user, is the same as this one. So I guess it's a bit confusing because we're using the same for the name of the intent and also the name of the context. You see here all the different entities you can extract from the result. So I can also add other entities. For example, if we would create a different intent about favorite foods, I don't know, I like banana. Then you can also add other kinds of entities here. And you see it will pop up in here. So you can actually return multiple entities if it's necessary. But in this case, we're only interested in the name, so I will delete it and we'll also delete here. Notice that I checked this required part because I'm only interested basically in the name. So what intent basically does, it looks at a sentence or a user utterance that's translated from speech to text, and it looks, does it look something like this? Is the intent is basically checking whether the user says their name, and if the user says the name, the intent is returned, and the entities are actually the parts of the dialogue that can be extracted and sent back separately. And you see here that it's the parameter name is name because that's a username, and that's basically this here. So you look, okay, where there are intents where you don't have any parameters, so you don't need any of this stuff basically. You just need to check whether the result of the intent is actually the intent name, then you're done. But if you're looking for parameters, in this case the name, you check, okay, are there any parameters in the detection result? Yes. And is the specific parameter that I'm looking for, is it in the list of parameters, in this case name? Yeah, and if all those things are true, then you know, okay, the detection result has a list of parameters and the name is in there. I will extract the name and save it in my user model. And then I say to the reference or the recognition manager, attempt is success, yes. So then this will drop out and it will reset the recognition management. If you want to reuse it again, in this example, it's not necessary because we're not going to use it anymore. But in your case, you likely are going to ask different questions. You want to reset it. And it basically resets everything like it was when we initialized it here. So then, thinking about speech recognition, there are two options when we arrive at this point in the code. Basically, we'll make it full screen again. Basically, it dropped out because either you ran out of attempts or you successfully acquired the name of the user. And you can check that here. If the name is in the user model, then you can use it. And if it failed for some reason, you have some alternative dialogue. So when designing dialogues, you always have to think about what are all the options that can happen. And in this case, it's either I got a name or I didn't. But in some other cases, there might be multiple options, and you need to have different branches of dialogue dependent on what kind of other actions there are. And at the end, I prefer always to do the rest action, because if the robot is constantly awake, then its motors are on. So if you're developing code while the robot is basically standing up, it might overheat. So I typically end all the applications with just the rest function. If you're going to do a lot of rapid testing, you can just comment it out for a while so that you don't have to wait until it's going standing up, sitting down, standing up, sitting down. But make sure the robot is sitting down when you're just coding away and not letting the robot overheat. So basically, this is a big overview of how the speech recognition works. Just to give a small example of how you would create. So this is a very specific question where you're just asking for someone's name. You're looking for specific input. And a lot of intents look like this. So I think for me, most of the things are in Dutch, by the way, because my robot has to talk to Dutch children. So a different example, I don't think I have anything in English here, but I will switch it quickly to Dutch. Doesn't really matter. This just looks the same. So it's just, okay, answer favorite animal is the context. I have a few training examples of how children might answer this question about what's your favorite animal. And then I extract a list of animals. Animals is an entity I created myself. So there are some built-in entities like the given name. That's something that Google provided already. But in most cases, you want to create your own entities. So that's just, you have the intent tabs here and you have the entities tab. And you can just create an entity, which is just nothing else than basically a word list. So just going to the animals, note again, they're all in Dutch. I have here 13 pages of all kinds of different animals. Basically, I just scraped Wikipedia for all the animals that I could find. I think, there are hundreds of animals in this list, and it will just correctly recognize the right animal. So this is one way to define intents and use entities to extract information, but there are also cases where you have a context where you're looking for different intents. So users can respond differently to the same question. And the prime example that you're definitely going to use are yes or no questions. And that works slightly different. Let's just go to the answer yes intent here. So this is an example of an intent that only tries to recognize if the user is basically giving a positive answer, yes, or sure, or maybe I have English examples here. Yeah, fine, why not? Yeah, okay, what, all those things. And you don't have any entities here. So you only make sure that you have an action name here that basically tells your application, okay, the user says yes. So if we go to answer no, we'd see it's basically the same, but just for no. But the main difference here is that it has the same context. So it has the answer yes, no context. It has it both for answer no and answer yes. And also I added a don't know. I don't think I have English things here. Again, I have it in Dutch. So if the user says, oh, I don't know, or maybe, or sometimes, or depending on where you're going for, you can include these things in the, and this also has the answer yes, no context. So if I'm going to ask a yes, no question, maybe I can just do it here. It will look something like this. I will just copy this part, and or maybe I will do it after this part. And now it's better to, so you can either reuse this part, or you can create a new one. I think it's better to reuse it, but for now it's a bit more rewriting than I would like for this tutorial. I will just create a new callback. So I will ask the user if they like chocolate. I can basically copy this part and also copy this part, because that's the only thing that I would need. This is a bit different. Now I can distinguish between different types of answers. So I will use this. So this will be sent back. The answer yes will be sent back if the user has said yes to the question, and then I will add it to the user model. I will something like this, and you always have to make decisions what to do in ambiguous cases. So for example, now I will treat answer no and don't know as a no, basically. But you can decide whether you have a separate response for a don't know, or whether it's part of the yes or part of the no answer. It's all up to you, depending on what the dialog needs. And these labels, they all correspond to this action parameter here. So you can just copy and paste it to make sure it's all spelled correctly. And now I can add something like this, and make sure to not forget to do this. Otherwise, it will not break out of the loop, or it will think it's a failure. Or it will, in that case, it will ask the question again, although it successfully recognized it. So now it's complete. Of course, you can integrate this more smartly in one. So now we're going to use for this question here, this callback function, and instead like this, do you like, and now we're gonna use the context yes, no, and that again corresponds to this context here, which is the same for an answer yes or an answer no or an answer don't know intent. I've changed some stuff, so I wonder if it still works. Let's just run this code and see what happens. I will enter the video here. Very curious. So this screen pops up because I connected it already to the robot. You need the screen to pop up with all these things in order for it to work. If it doesn't pop up, then you are not connected properly to the robot. So make sure you are and get this screen, and you need to select them all and then run OK. And then the robot will stand up.
Hi, I am now. What is your name?
We'll ask this. Hi, my name is Richard.
Nice to meet you, Richard. Do you like chocolate?
Yes. I didn't do anything with the response, so maybe I can add that really quickly here. If likes chocolate. So if it's in the user model, you can use it, and now we can actually distinguish between different responses. So if so this means basically it's a Boolean function, so we can just call it like this. If it's true, then we're gonna call ActionRunner, run waiting action, say that's something like and in any other case, I want to do it like this. So I can do it like this. So let's run the example again.
Hi, I am now. What is your name?
My name is Bob.
Nice to meet you, Bob. Do you like chocolate?
Yes, I like chocolate.
Do you like chocolate?
Yes, I like chocolate. It didn't understand. Somehow it didn't detect it. Interesting. So this is where I started my Docker. I can see the transcripts here, and I can investigate what happens. So last time, oh, there is some kind of big error here. So last time it successfully detected an answer yes. I like joking, all right. Okay, so you see that the transcript phase is not always correct, but it should have recognized the text. So these are things that still might happen. We solved part of these problems differently, but I won't bore you with it now. So this might happen. So if I run it again, there's a big chance it will happen, or not happen again.
Hi, I am now. What is your name?
Hi, my name is Stuart.
Nice to meet you, Stuart. Do you like chocolate?
No. So now successfully recognized no, but it didn't say this. Let me check real quick. This should be an or, yeah. All right, this is live debugging. And oh yeah, I see in the comments, thank you. So I will run it a final time. Hopefully it will work now this time. Oh, this one I want.
Hi, I am now. What is your name?
Hi, my name is Mohammed.
Nice to meet you, Mohammed. Do you like chocolate?
No.
Yeah, I don't chocolate either.
I have that text here. All right, it now worked as we wanted it to work. Only it didn't say the proper text because I didn't write the proper text. But this is how you can add yes, no questions also to your speech recognition code. So I see we're now an hour in. How much time was allocated for this tutorial? Do you know how much time do you have? Can someone answer that for me, please?
Yeah, wait, I'm trying to find what Koen said in the chat.
I think it wasn't specified, and I think that many of us are actually like having a lab session right now. Like not the people who are here, so it wasn't like scheduled for everyone to have time.
Someone says 12, so yeah. So let's go to your questions. So what I can show you also is how to create gestures without using going through the choreograph route. So you can also create gestures with the robot, then save them in a file and then use that file instead of having to create something in choreograph and then upload it to the robot. So I can show you that. But maybe before I go on to that, are there any questions so far about the speech recognition or Dialogflow examples? Or are there other kinds of functionalities you are more interested in than the gestures of the robot?
I'd kind of like to know how we can like use the memory of the robot. So for example, that when we turn it on and it gets to interact with a person that it hasn't met before, it does like an introduction, like when it meets a new person, but when we turn it off in between and then turn it on again and it sees the same person, it will be like, hey, I know you, and it can access what it saved before.
Yeah, that's a good one. I'm not sure if memory is implemented here. I think it looks like it's commented out. So there is no memory functions available through the Python API. But what you can do is create it yourself. You can just store user models things either in some database you're hosting somewhere or run somewhere, but for very simple interactions, you can also write it to a file and then read that file. just for demo purposes within the course. Of course, if you're gonna run it in a real in a production kind of state, then you definitely want to have it secure in a database somewhere and not a file on a laptop somewhere. But I think that's the most easier route, is to just write the user model you create to the file and connect it to some kind of user ID, and then either connect it to, I think maybe face recognition is a bit too fault sensitive, but you can also, what I typically do in my experiments is that I'm the one who, I know which child and which the participant number of the child is, and I make it a variable at the start of when I run the program. And then basically based on that ID of the user, I load in the user model that I created from previous sessions with that user. And then I can access that information during the interaction, for example, extract the name, or extract the age, or extract other things that you've learned about the user, and add it to the dialog. So I think it's a bit complex to do it in the half hour remaining for the tutorial. But I think just basically with simple Python, you can solve this problem by saving it somewhere, either a file or a database, and then extracting it from that file or database, and using like string replace functions to, I don't know, create some kind of variables in your text, and then replace those variables with information from the user model. That's basically how what we call templated dialog. So you have dialog. I will just go to the speech recognition here. So you have here the user model. This is also kind of templated dialog. And instead of, you know, if this would be like session 2, instead of nice to meet you, is like, hi, nice to see you again, Richard or Bob or whatever. You can, during the initialization phase, load in like an existing user model from a file and then use it like this as well. Hopefully that answers your question a bit.
Yeah, it does. Thank you.
Yeah. Other questions? So I see in the chat, is it possible to do face tracking and not just face recognition? So you mean trying to look at the user, and if the user moves, that the head of the robot moves? Is that what you mean with face tracking?
Yeah, I asked the question.
Yeah.
Yes, that's what I want to do.
Yeah. If in the autonomous behavior of the robot that's standard installed, there is a small face tracking algorithm installed. So now the robot, I will show it here, is in rest mode, but if I press the button twice, it will activate and also be activated in autonomous live mode. And there is some face tracking in there. It tries to base its face on using the camera, but also sound, to trying to locate where the speaker is. And I'm not sure if it will, yeah, so if it recognizes me, I'm not sure if it's visible on the camera, but then it will color a bit purple here. So you can play around with that to see if that's sufficient for you. So it's pre-installed functionality, but it not always gives the result that you want. For example, if someone else walks by or something, it might turn its head or something like that. but you can try around and see if you just activate that behavior and see if that's enough for you.
Thanks.
Any other questions?
One more question.
Yeah.
When I try to set the colors, for example, for green, it set the colors right, but right after when I try to make it say something, it went back to white.
All right. And you used the set LED color functionality?
Yes, of the ActionRunner. I tried loading them and running with the run loaded actions and also just run waiting actions, but it was the same in both cases.
Okay, yeah, it should, how the way it should have been implemented, and I'm not sure what caused, maybe we can just try it out in a minute. It should just remain the color until you either reset it or give it another color. So we can try it out real quick, see what happens. I will just create a new and I will just, I don't know, quickly copy paste this and remove all the things I don't need. First, let me see what the thing is called. Something like this, set that color. And the LEDs and the color list. I think the rest is all default.
I used to set ear color and eye color. Is there a difference between just setting the LED colors?
Good question. I think in those cases, it will just set the color specifically for the eyes or the ears. So it shouldn't do anything different. So I can just use that one. And it just needs one color, I think.
Yeah.
And then you said you made it say something, but during the once it started saying something, it was reset back to white, right?
Yes, yes.
Yeah, let's see what happens.
Hello world, am I still green?
Yeah, they're still green. It's not clearly visible in the camera, but the eyes are still green. So I'm not sure what caused this problem on your end.
Okay, thanks. I'll try around more.
Yeah, yeah. And for those interested more in setting the eye colors, you can also use what I started to do was set LED color. You can actually set individual LEDs. So this changes what we see now is that it changes both eye colors completely the same. But we can also use this and then call individual LEDs. Let me see if we can. think there is a list here. Well, this is not even the most up-to-date. So this is just now key documentation from the robot itself. And there are, depending on whether you're using the now or the pepper, but in the case of the now, there are all kinds of LEDs you can use. I think this is maybe even this is maybe even both. So, for example, in the eyes, there are multiple LEDs. So it's not just one LED, it has basically fragments. So you can create a whole color palette of things. Usually I just stick to using groups as well, because otherwise it's very annoying to create very specific colors. But if you want to have the right and the left eyes a different color, you can use, for example, right face LEDs and left face LEDs. Going back to the example. So now we're gonna, I think it's a list. So it's a list and a list. So we're gonna change the left or the right and the left face LEDs. And we give them different colors, for example, blue, the visualization letters, red. So the first position in the list here, they match with the first position here. And again, so the right will be blue and the left will be red. Let me see if there are any other things we need to specify. No. And I will reset them to white at the end. Otherwise, they will remain the color even if your program stopped. Let's see what happens.
Hello world, are
Yeah.
my eyes still blue and red?
So you saw them change color to blue and red and then back to white again. So that's basically how you change different LEDs. And like I said, you can do it on an individual level for each LED separately, or you can create combined groups of LEDs. And in the documentation that I just showed you, you can find which groups are there and how and what their labels are called. All right.
Can I just ask one more question regarding
Yeah.
that? So, for example, like in this example that you showed, like if we want to make the change or like the reset to white, based on the answer of the user. So we just like put kind of in between that it should wait with this resetting. If so, for example, if the user says, yes, they're still blue and red, then it resets. And if the user says no, it doesn't reset, for example.
Yeah.
Okay.
That's possible.
Yeah, okay.
Yeah, so that's basically the thing we've seen here in the speech recognition example, where you would then do something different. So you can, instead of the say action, you can also use the color action of the set LED color. And you can even ask the user, like, what's your favorite color? And then use that as input for the set color action as well. Mm-hmm. You can actually use the input of the user to change some stuff on the robot dynamically. Other questions about this? Or any other questions about different functionalities?
Yeah, I have a question on what we were talking before about the robot following a face with like its head.
Yeah.
I have also seen it done, that the robot does it like on its own, but I was wondering, or I didn't understand if we can implement this in code.
That's a good question. I think, I'm not sure if the animated behavior is something you can. Yeah, so the set idle and set non-idle is something you can use in code to activate or deactivate the autonomous mode, which is and the face tracking behavior is part of the autonomous mode. And in this case, you need to set non-idle views to activate the autonomous mode, because it used to be that it's default activated, so you could set, well, if you don't want it, you want to set it to idle, because sometimes it interferes with things you're doing. So sometimes you want to just deactivate that autonomous mode, because it can, I don't know, if you're doing specific head movements or something, that can be overridden again by the autonomous mode trying to track a face, and can, you know, combat each other. So in those cases, you might want to set it to idle, but in all other cases, you can set it to non-idle. But I think some of the robots start up in autonomous mode, and others, we have deactivated it. I'm partly responsible for that as well, because I always want to have full control over the robot and don't use the autonomous mode. So you can set non-idle to activate the autonomous mode, which includes the face tracking algorithm.
Cool, thanks a lot.
Yeah. Other questions? All right. Then I will, I think the final part what I will demonstrate is the creating gestures using only the Python API, so you don't need to use choreograph and install stuff on the robot. So if you switch between robots, you don't, if you're using the choreograph route, then you need to make sure that if you use a different robot, that the gestures you created are installed on that robot. But if you want to prevent that, sometimes you can, for example, there are a lot of custom default gestures available in choreograph, and you can use that by using the choreograph route. But if you want to create something yourself, you can use the timeline and create like record where the position of the joints at specific times to build a gesture, which can be quite time consuming and annoying. But there is another way, and I pre-made an example. Let me find it real quick. I will just copy it here. So let me first go here. I think it's record. Yeah. So there are two functions that I'm using. That's the start record motion and the stop record motion. And basically what this does is you give a list of joints or groups of joints, similar like the eyes. I will show that in a minute, where you can find those labels. And it will record, basically, it will create the timeline, the motion timeline for you. So it will record the angles of the joints at certain times, and then you can use the play motion to actually play the timeline that you created. So I'm using start record motion, stop record motion, and play motion. I think in the abstract connector, there are again, yeah, that's here. So like I said, you need to have a list of joins or chains of joins. So I'm opening this documentation here. And what you see here is that basically for all the degrees of freedom that the robot has, you can include it in the recording. So again, I typically use like things like the left arm or the right arm. If I'm instead of all the specific joints themselves, so you can individual record the pitch or the roll of the shoulder and stuff if you want to do that. But typically it's not practical to disambiguate this in this level, but just use the big labels. And if you want to record the whole body motion, you can also call body. Although in most of your cases, I think you want to stick to just the arms because if the robot is standing and you're manipulating the legs, it can get quite unstable and it already falls over by doing nothing, basically. So I'm warning you to be cautious in creating gestures with the legs or stuff, unless the robot is, for example, lying on its back or something. Maybe if there is time, we can create like a fun little baby animation or something. But first I will demonstrate the regular thing that I prepared. So to the examples, I have a motion recording example. So what I'm going to do is I'm going to save the motion recording in my application in this variable. But if you want to reuse it outside of this one application, so what you typically probably going to do if you're going to use this route is you're going to create a separate application just for recording motions, and then you want to output the result into a file. And the motion recording is by the system by default already outputted in a JSON format. So you can just store it in a JSON file and then use just simple Python code to import or load in that JSON file. And then you can use that as in the play motion as well. But for now, for this example, I'm not saving it to a file and reloading it again. I'm just keeping it stored in this variable. And I'm only going to record the left arm and the right arm because I'm going to create a gesture with the hands or the arms and the hands. And the rest is just the same as the other examples, just loading the SIG system. And then, oh yeah, what I forgot to mention is that very important when creating motions is that the stiffness of the joints are set to 0 before you're gonna move the robot around. So now it's in rest mode. And as you can see, I can freely move the arms, but once I'm I was too quickly. So now it's in the inactive mode, and now I can't move the arms. So in our example, we want the robot to be standing. So I'm calling the wake up action, but it means that all the joints are stiff. So that's what the first thing I do here is I set the stiffness, which is just another function that gets a list of joints and the stiffness value. And the stiffness value is between 0 and 100%. So I'm going to set it to 0% so that I can move them freely. I let the user know that they can hold the arms and move it around, and then I'm gonna do the start record motion. Notice that I'm using a run action here instead of a waiting action because I want to control how long the robot is waiting or the program is waiting. And this is basically the record time. I'm just going to use simple Python sleep which is just imported here. Just a simple Python sleep of 3 seconds. Then the robot is going to count down and stop the motion recording. Using the additional callback method, I've defined a callback function to process the output of the recording, and that's basically that timeline that is created in JSON format. So I have here, and it's basically formatted in a JSON string, and I'm just storing it in the motion recording variable that I created. And then if I'm going to set back, this is very important, the stiffness of the joints to 100, because what happens if I don't, then if I'm calling the play motion here using the motion I just recorded, the robot will not move because the stiffness needs to be, well, 100%. I think it can also be 80%, but I think, you know, for all practical purposes, you want to just set it back to 100 again. That's the default value. Then it will actually move. So with like setting the stiffness to 0, it won't move. So don't forget that. And then it will basically replay the motion that I just created. So let's just run this script and see what happens.
Three, two, one, and done. Amazing. Let me replay that.
So it basically just did exactly what I did and replayed that. And like I said, you can also store this in a specific file, and you can just create a whole folder full of different gestures that you then can load in during the interaction whenever you need a specific motion. And it works pretty intuitively by just moving the arms around to create something like a little dance or a specific gesture. So this is an alternative route compared to the choreograph route, that you don't need any other software or don't having to remember to install choreograph files on the robot. Yeah, just around with this. Yeah.
Is it possible through this record motion to also, how to say, like the fingers of the robot are not part of the right or left arm? And when I went to the web page that you showed us that has all the joint names, I just failed to see the fingers. So I just wanted to make the robot point, you know, so to also have the one finger out and the other fingers in a fist. Is this still possible using this function?
So the fingers, they only, if I'm looking at correctly, they're not part of this.
Yeah, that's also how I thought.
So basically the fingers, they only have an open and close function. So it's just basically 1 degree of freedom that it can do just basically this or this.
All together, all three
together. So you can't manipulate the fingers.
Okay.
So pointing will always also be, I will open the video again. Something like this.
Yeah.
So it can't do like,
it's
possible to do this.
Awesome, good to know. Thanks. I will stop trying.
But I'm not sure how to actually control the fingers through the Python API at the moment. If it's not part of this, then it's not possible to do it with the record motion, I think. But at least
it's just
graph, you can at least like do open and close. That's possible to graphs.
Yeah. Awesome, thank you.
Yeah, no problem. So we have like 2 more minutes. Are there any other questions? I will add this example to the Python API repository. So if you pull a new version or look online in the live, this will be added later today, so you can also have a look at it.
Can I ask you also maybe if it's possible to upload somewhere screenshots of your Dialogflow answer yes, no intent, if possible?
Yeah.
Thank you so much.
Yeah. I will do that as well. Let me write it down. All right. Any other questions? Well, thanks for coming, and hopefully it provided some insights. Might be a bit chaotic session, but hopefully it gave you at least enough information to know where to look for and give you the confidence to just play around with it. And with some simple things and with additional Python things, you can, I think, get quite far. Just think about how to structure. That's the only thing that we didn't really discuss is to how, and there's also not part of the examples, is how to structure like a bigger interactions. So that's something you have to think about yourself, using your knowledge about software engineering and stuff like that. They also apply here, of course. If you want to create bigger programs, then you need to have some way to prevent reuse, copying. If you find yourself copying parts of the code, then I can extract this and make a module or a function or whatever out of this and reuse the code. So try to find those optimizations as well. It makes I think the readability of your code a lot easier, and also you can get build your interaction more bigger and bigger if you create like solid building blocks for yourself. So thank you for your attention, and good luck with all the different interesting projects you have.